Hi everybody, this video is going to go through our plate tectonics has-bought activity. We're doing activity 3. So I encourage you to follow along. First watch the video, but then if you have any questions, go back into the activity. I'm not going to show all the videos that are shown here. I'm going to go ahead and click begin activity. We'll start off with the first part. Earth without water. This refers to if we were to take the ocean away. And I know WeVideo has a hard time with showing videos. I'll go ahead and press play and see if it works, but I'm not going to have any sound. So what we're taking a look at here is what the Earth would look like without any water. And what we're seeing mainly is as we go through the ocean floor. And what was discovered post-World War II is this line of mountains in the middle of the ocean called the mid-ocean ridge. Pause it there. And so that's kind of the focus on the first part today. So the first question, what do you think caused the mid-ocean ridge? Move on. Earth's plate system. What we're looking at here is if we take a look, earthquakes and volcanoes tend to form at plate boundaries. Some volcanoes, some of them can form in the middle of plates. But if I go ahead and click data type, click earthquakes, volcanic eruptions, and get rid of that and go ahead and press play, start, you will see that a pattern occurs. This pattern outlines what we call the Earth's lithospheric plates. You'll see that earthquakes do occur around Minnesota. There was an earthquake in western Minnesota in like 1975. It's really not showing it here, but I think because this data doesn't go back far enough. All right, let's focus on the South American plate. If I zoom in a little bit here, you can see around the South American plate, remember we have a convergent boundary here where this plate called the Juan de Fuca plate is being subducted underneath the South American plate. But what's going on over here is kind of what we're taking a look at today. I'm going to go to the next page. So what's happening in the Atlantic Ocean? We're going to take a look at a geologic profile of this. And what's forming is the mid-ocean ridge. If we take a look from P1 to P2, and we have a graph of, let's zoom in for you. The mid-ocean ridge is here, South America, Africa, and you can see a distance grid. So from P1 all the way to P2 is about 6,000 kilometers. Okay, a couple of good questions here that I'll put on the Ed puzzle right now. And we'll move on now to this map. We're going to take a look at the depth of earthquakes along that mid-ocean ridge. So I'm going to go click data and earthquakes, and I'll go ahead and do prior to 1980. No, that's volcanoes. Okay, I'm going to go ahead and press start and get rid of this. So look at the depth of the earthquakes along the mid-ocean ridge. Remember, depth we can look at with this key. Okay, you should have seen that earthquakes tend to be very shallow along the mid-ocean ridge. So that indicates there's really no subduction going on there, if you remember that from previous. So what is the mid-ocean ridge and why is it considered a plate boundary? It says mid-ocean ridges extend for over 56,000 kilometers under the oceans. Scientists have mapped mid-ocean ridges and sent submersible vehicles to these areas to collect samples. So we're going to take a look where two plates are moving away from each other. So here we have two plates of oceanic crust. Once they move, let's go ahead and take a look what happens. I'm going to go ahead and click next. I'm not drawing any continents here. All assigned forces, I'm going to have these move apart. These are called divergent boundaries at the mid-ocean ridge, move apart. And next, I'm not going to worry about ordering the plates, and finish. And we're going to watch it start to go. Okay, so at a mid-ocean ridge, the two plates are moving apart. And you can see volcanoes forming along the ridge that forms the mountains, and earthquakes occurring as well. Remember, those are shallow earthquakes. Let's go ahead and draw a cross section of this area. And we can take a look what's going on at the mid-ocean ridge. Start. Okay, so as the plates split apart, magma from inside the earth wells up and forms the volcanic mountains under the water. Actually, Iceland is where the mid-ocean ridge is coming up above the water, so it can peek its head above the ocean surface. Okay. Moving on to the next. This slide, this shows Dr. Furman here explaining why there's no gap when the plates move apart. And this video here, if you want to take a look, zooms into the mid-ocean ridge and looks at the volcanic activity that's occurring. So essentially what's happening, I'll play this one because I don't think there's any sound to it. This is actually exploring the volcanic rocks on the ocean floor at a mid-ocean ridge. And so what's happening is the rocks, as they come upward, solidify, right? And so they're forming solid rock. That's why there's no big gap into the earth at the mid-ocean ridge. Now we're going to take a look at a model of the South American plate. So I'm just letting this load, sorry. It says run the model to see what occurs and rotate it so you can see the left side as well. So I'm going to go ahead and, if I can get to the bottom here, start. Okay, we're going to let this run. We can see again along here is the convergent boundary where you're getting the Andes Mountains formed. But let's turn this around and take a look at where the cross section is. All right, the cross section, we can see the mid-ocean ridge is forming between the South American and African plate is what that would represent. I'm going to go to the next one. And this talks about transform boundaries. So we had convergent boundaries where they come together, divergent boundaries where plates move apart, transform boundaries occur when plates slide past one another. So as I let this load, it's kind of, there we go. And so what we're looking at here, here's the divergent boundary. And what's happening is the crust is broken and it's just sliding past another plate here. And so I'm going to go ahead and press start. And so I'll zoom in here so we can see. As you can see, these are sliding laterally. This plate isn't moving up above here. So this plate and that plate are sliding past. We call that a transform fault or a transform boundary. Now you'll see what's occurring there are mainly just earthquakes. No landforms tend to be created at transform boundaries. So this question, what happens at a transform boundary in Tectonic Explorer? Select all the correct answers. So I will put that in the Ed puzzle. Here's a picture of one where you can see the ground has been displaced. And finally, let's take a look at the San Andreas Fault. I'll get rid of volcanoes. Press play. So the San Andreas Fault, you may have heard of it. It's a transform fault that runs pretty much the length of California, from Los Angeles, actually Southern California, all the way to past San Francisco. And look at the different earthquakes that occur. They tend to be surface volcanoes, very shallow, but they can range in severity. If we take a look at our key again, the size of the circle indicates how strong it is. And so you can see some very large ones. And if you've ever heard of what goes on in California with earthquakes, you know that they can get some pretty strong earthquakes. But these are shallow focus earthquakes. No subduction is occurring there. Okay, almost done with this. When we take a look at all of Earth's plates, what we see here is how the different plate boundaries are forming. The blue lines or teal indicate divergent boundaries, yellow are convergent boundaries, and the pink are transform boundaries. Okay, a couple of questions here that we can ask. Here's a close-up of, here's the divergent boundary of the plate, the blue, and how the transform faults can occur along a mid-ocean ridge. Okay, our last page, how do they interact? The main point of this is the idea that if we take a look at the Pacific plate, understand that plates can interact all different ways. If we let this go, you would have some transform boundaries along, some convergent and some divergent boundaries. So if we were to take a look at the Pacific plate, that's what we would see. Okay, so good luck. We'll continue tomorrow with a short ed puzzle as well.